Okay, my friends, this is going to be fun. This is so simple, it's unbelievable. This is what is called the ultraviolet catastrophe. They claim that the atom, as you heat it up, you see this is heating up. Heat, 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 heat. Okay, what happens here, this is the wavelength, how long the frequency, actually it's the spin. Now, when you get up hotter and hotter and hotter, the frequency gets spinnier and spinnier. And what you end up seeing is light. Down here it's just ultraviolet, infrared. It just warms you up. Here you start to see a glow of red. Then as it gets hotter, the red goes away and you start to see only green. And then as it gets hotter, the green and the red both go away and you see only blue, and it's getting hotter and hotter and hotter. And then as the blue goes away, it's gone. There's nothing left. So the whole temperature drops back down to zero. This is the catastrophe right here. They say, how could that possibly happen? It should be getting hotter and more things giving off. There's nothing left to give off. You started with the red. All the red goes. Bada, 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 boom, all the reds. By the time you get done, okay, I'm sorry, my friends, I dropped the dark matter and it fell, and it took me 5 minutes to find it. Now, inside of all of those particles is the dark core. And by the time you go past the blue and it's gone, there's nothing left. So all you got is the dark, and it drops like a rock. I show you this, and I probably have shown it to you 5 times already, or whatever. You're going to see it for sure. All right, I'm going to talk about something called the ultraviolet catastrophe. And what happens is, at a certain point, particles are giving off, and all of a sudden they stop giving off. They should continue to give off, but they don't. They stop giving off. And they can't understand why that happens. They call it a catastrophe. It doesn't follow the law and the rule. I know exactly why it happens. There's no particles left to give off. It's as simple as that. You see this? This was done by the Russians in space, and that is literally just exactly like this, a black hole in the center, which is collecting radiation around it, which is the white particles. They start with the blue, then the green, and then by the time you get out to the way outside, they're the red, just like this. Now, the hotter it gets, the more particles radiate. So the red starts to go, and it just goes kind of easy, and then this, and then that, and then by the time you're at the bottom, and then you hit ultraviolet, there's none left. So it crashes, no particles left to shoot out. Part of the problem is they don't understand what heat is. I'm serious, I don't think they understand what heat is. Heat is free electrons. Those are those little white particles you saw around the black ball. They're free. And once you force them into something that doesn't want them, it creates that push to shove, and the heat goes up. Now, the red ones, they push back kind of easy. So you know, at the temperature of the Earth, yeah, you don't have too much push to shove. You don't have too much, you know, the wavelength's got to get up to where it's really cranking, up to where a light bulb is giving off a certain amount of heat. I don't know what kind of light bulb they're talking about, but let's just get into where you're actually seeing red. See, down here you don't see anything. This is what they call the infrared. It's just kind of warm, but it doesn't radiate enough heat, enough light for you to actually see something glow. Now we're up here at this temperature where light bulbs are giving off light. Now, they're giving off red. No green, no blue, no nothing yet. As it goes up, they start to continue to give off the red, and then they start giving off the green. No more red. The red's gone. That's because all the red out here is gone. So now they're into the green down here. And as that starts shooting off, because that's at the temperature of the sun and up to here. Now the green's gone. So now all we got left is the blue. The blue is all that's left around the black, and now all of a sudden the blue is completely gone. Nothing left to shoot out. This is the catastrophe, the drop. Simple as that. Done. I'm going to try to explain it very quickly. I was in electronics, and one of the things that I did was scales, weight scales in supermarkets and so forth, and we had to go in and calibrate them every so often. And we have these screws that once you do the calibration, you put the plate back on with that screw. It's got a hole in it. Then you run a wire through it like this, through the lead seal, and this was my seal, and I would just stamp it like a seal from the King Roger, and that was my number and so forth, and that was it. So the reason I'm showing you this is we had to calibrate scales, and guess what we had to do? We had to make sure the temperature was the right temperature as the weights as the scale. You say, well, why would that matter? Things don't weigh the same when they're cold or when they're hot. Did you know that? Something weighs different when it's hot, and when it's hot, it's heavier than when it's cold. Most people think it's just the other way around. When it's cold, it's heavier. It's only cold gases, cold solids are lighter than hot solids. And that's because the hot solid has extra particles, has extra of these. All right, well, actually has extra of these, the glowy ones. All right, these are the dark particles. And they make these in the photons. But you can break these up, as I show you, and then you end up with these, the black and the whites. And it's just because they're hitting huge particles, they're getting all this debris. And it just, these are the ones that are way in the middle somewhere in the zoo. Here's what it should consist of. From a proton and up. So if for some reason there's some natural vibration that holds together 1,823 of these dipole electrons and puts them in a ball, makes them right into a ball like this. All right. If they don't have that many, they just fall apart. They're all over the place. Less than 1,823, you get a zoo. You get this kind of stuff. You don't know what it is. They're all over the place. Now, once you understand that it's only made of dipoles, there's two dipoles. I'll show you them in the light, because all we used was light, and we accelerated it through a Venturi, and we got these exact particles, we got these exact particles, we got these exact particles. And what I will show you is exactly what they're saying at CERN and Fermilab. As a matter of fact, these are the particles they say they want to find at Fermilab. We found them right there. Here they are. And here's the glowy one, and here's the dark one. And Fermilab, the people from Fermilab think I'm an idiot. And they treat me like an idiot. Very, very unbecoming of them. And I became a little unbecoming back. I'm fed up with these people that they get in these jobs. They're not capable of doing the work. So they tell you to go get lost. Now, this is the particles they're looking for. At Fermilab, there they are. Now, not only that, we were able to separate those. That's fission. When you can break these two particles apart, that's called fission. The white squirted through there, and then they came back together. That's fusion. Fission and fusion on the desktop. That's the muon, which is the black one. It never changes. The white one turns into a shower. And that's because of the medium. If you go from, and they actually just did this, proved exactly what I'm saying. Light from thin air. Exactly what I said. The article came out, I think it was yesterday. But they're using biology. They're collecting the light through the biological tubes. We're collecting it through a Venturi. They're never going to get the energy we're getting. Never. Okay, my good friends, this is what is not understood. The black body will absorb any radiation, any of these colors. Every black body is made the same. They'll absorb any single one of them, and they will suck them in as hard as they can, depending upon the size of the black body, how big that black body is. The bigger it is, the more suction it has, and the more particles will collect around it. Now, it will emit radiation only as a function of the temperature. So it's normally stable. Let's say 20 electrons just floating around out there. That's stable, no problem. You heat it up, a couple get pushed away. Now that's radiating this black body. And the hotter and hotter and hotter you get, eventually there's no particles left. All the blues go and you drop right to the bottom. You see this? Up at the ultraviolet, there's no more electrons left, so they're gone. But you still got particles. You have the big chunks, and the temperature drops dramatically, but the power of them is still, they just knock you over like a bomb. All right, like I said, this is very, very simple. Black body, the black core will suck in every radiation, every different color, and it will emit all the way up until a certain temperature, which is here, and the blue is gone. I told you, the red, once that's gone, it's gone. Then the green goes up and it's gone. Then the blue goes up and it's gone. And then you don't have any particles left. But you still got bombs coming out of there. You got nucleus particles coming up, protons. Now you got, well, they're actually not protons, but they are the, boy, this is where it gets a little tricky. They're the black particles. They're actually dark matter, they're muons. I don't think they understand that either. All right, you see this? Gamma rays have the smallest wavelengths and the most energy of any wave in the electromagnetic spectrum. They are produced by the hottest and most energetic objects in the universe. And they're talking about neutron stars, pulsars. Well, we produce them here in this collision against themselves. Okay, here they are right here. The muons have separated from the white particles. The muon neutrino, the electron neutrino. These are the smallest particles that exist. I never thought ever that you could have a bar magnet become not a bar magnet anymore. Because you keep cutting bar magnets down, you will never get anything but a bar magnet. It will go smaller and smaller and smaller. Still a bar magnet. However, here, there's nothing left to go any smaller. You break this piece right here is one magnet, that's another. But now we broke these particles away from those, so they can separate, yes, but only at this level. Anything above this, they're stuck together, and you break them, you get a bar magnet and another bar magnet. That's like what they call them gluons. They're actually electrons because they never knew that the dark matter existed with the white matter. All right, which is just what I showed you right here. That's an electron, and that's an electron. They would call it a gluon, which is the point particle attached to the fixed particle. The fixed particle never changes. They never change. That's the fixed particle, that's the point particle. This is understood. They just can't do it because they're trying to smash gigantic particles together, and then they treat me like I'm an idiot. And we could be using this right now, I think, right here, to get free energy, and it's just denied for Alright, there's really no reason we shouldn't be able to get free energy from here. They're just doing it right now, but they're using plants. Plants, well, they're using biology. And all they're doing is harvesting energy just like a plant would to make it grow. That's how it grows. It sucks in the energy. It sucks in the electrons. Right here, these ones, well, it takes both of them in. But for us, we want to separate and get the white away from the black and use the white as just a raw energy source, and it is powerful as hell. This is where you can get your power. I think I can show you most of this very quickly. These are the particles. You see them? Those are the photons. And this is not something that I'm making up. I'm showing you the actual picture. You see this one here? That's a neutrino. That's a neutrino. They don't have the full-fledged power yet of a photon. And then they have all different flavors of neutrinos. The green ones are exactly the same. Exactly the same as the red. They also have neutrinos. Now, what do we see from CERN and the rest of them? Here's their little doodle that shows exactly the same thing. They show these exact same particles. This is the exact one I just showed you of ours. And then they show they can break apart because they're smashing these parts. Boom! They're hitting two of these together and they're just getting trash everywhere. And they're seeing the same particles we see. Then they're seeing oddball looking ones like the neutrinos, yes. Then they're seeing the black, or it is black actually, but they can't put it on that black background. Black, and then they're seeing blue with it, or red with it, and then they're seeing green with it, and then they're seeing, what did I say, blue, green, and red. That's what they're seeing. So these are all the particles breaking off. And what they're doing is they're doing this. they're smashing all these particles off until they get down to the center, which all they got left is the black particle. They don't realize this. They don't realize what the particles are and how they're glued around. I mean, I always thought they understood this, but they just obviously don't. And when you break down into here, inside of here, it's also constructed of particles that will break apart and come back together. As I showed you, they want to be dipoles. They just want to be dipoles. That's their mission in life. And they want to be just like this. All right, that's light, but in a mass, they would be all together, except as soon as they hit 1823, they turn into a proton. And you get bigger or smaller. 1823, 1824, 1825, 6, 7, or right around that number, it's still going to be pretty stable. And that's what molecules are made out of. And that's why there's isotopes and everything. There's a lot to talk about here. But I think I've made a pretty good case for what I'm saying. This is what the catastrophe is. By the time all your reds are gone, then all your greens are gone, then all your blues are gone, nothing left. And look at the temperature. The temperature comes down to zero almost. The black ones have no temperature whatsoever to them. The white ones are just solid burners. And that's why it's the reverse of this. We're heating it up, but we're pushing them out. All right? An atomic bomb does exactly this. You want to see something amazing? This black is being shot through the Venturi. This is something Rod Warren did. He did some fabulous work. It's being shot through the Venturi, and the black stays the same size. So it's just the same little ripple of black. But the white gets glowing like this because it has to push out all the other whites. So now you get all this ripple effect. And the white has to concuss and concuss and concuss because the black's just going to keep coming. The black is the pusher. The black is the boson. It's the carrier. All right, and they all have the black and they all have the white. You see? And this is not something that's unknown. They called it the Dirac neutrinos. Now, this is what it should be. This is what the Majorna, they see them sort of halfway in the middle, and they do. They flip. It's called the muon wobble. So I think I've shown pretty good what we got going on here. And once you hit that certain temperature, it can't hold on to the electrons anymore. So now you have just a pure black body, or they've all radiated away. As soon as that cools down, it's going to suck them back together. The black desperately wants to find the white. You see it? It broke it here, but it comes right around. It digs right in it. Dig. And here it finds it's got enough. The energy is reduced enough where it can jump back in. Now this could be free energy. They say if you can do this, which we did, there's no question we did it. Absolutely no question whatsoever. And we do this all day long. This is a continuous squirting device. I think I got some videos I showing you, or will show you, shooting through some experiments I did the other day. Now, all the ones you saw here were done by Rod Warren from Australia, and I've lost touch with him. I hope he's all right. I don't know what happened. But he did all of this, virtually all of the best work was Rod's. Absolutely stunning. This here, this stuff, this. This was done by another guy, Fabian, but absolutely amazing. Absolutely amazing. And I don't see why we can't use this. That is no more than raw electricity. And if we can capture it quick enough and shoot it down through a photodiode, basically, and get it through that diode, and it can't come back. Bam, 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 because this is pulsation. Every one of those is a pulse. Boom, 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 boom. And when you put it through the Venturi, we're squirting it through there. And there's no reason whatsoever that I can think of why we shouldn't be able to harvest that energy right there. Right there. And put it right down through this. Stack it right into our battery. Use a little bit of it to keep the laser going. And you see that? That's energy, like unbelievable amount of energy. it was much more than we started with. I can guarantee you that. So it should be investigated. I don't know if there's any benefit here or not, but they just did something of getting light out of thin air. Let me show you. Basically, it's similar, but they're using plant life. We're using a crushing device. See this? I think I did another little clip on this, but I've been getting interrupted a lot. Clean energy 24/7. Engineers use nanotechnology to harvest electricity from thin air. And they say right in here, the whole key to it is these tiny little crevices that the light shines through, and you pick up electricity on the other side of it. Well, I can show you this on steroids. Wait till I show you ours of that. Now, of them, they show this thing, the light cascading through all these little filaments and it blocking the black particles and them getting a little bit of the electrical conductivity down. But they're only talking about very small devices and so forth. But it says electricity could be harvested continuously right from the air. It's exactly what I'm talking about. And if you put a little extra water in, I agree. Moisture in the air is just going to give you more resistance to electricity, give you more electron showers. No question. I agree with that 100%. Okay, everything that you see done here was done with these simple tools and a venturi. And a venturi, as I will show you, I use a grid venturi, which is like a screen. Rod used a single venturi line. Now, that's why you see mine like this. He's got this. Now, these are, well, anyway, I'll go over that in a second. I showed you what happens with the catastrophe is here. And the reason it is because around the black body, and I'll explain this to you about what the atom is constructed of. It's not exactly what they think in the standard model, not by a long shot. So the black body is in here. Now, it gets hotter and hotter, and as it does, it throws these particles off. Those particles literally leave. And by the time you get the red goes, then hotter the green goes, and then hotter the blue goes. And that's because they are arranged in this pattern. The black body is in the center, right here, and all these different colors are outside. The red just goes off easy, quickly. Then your green goes off, and then your blue, when that goes, it's done, and then it's gone. Everything's gone. Now, all you have is the black, so there's nothing else to give off. It drops like a rock. You can't give off energy, and the only way you can create heat, which is here, is to give off energy. You've gone backwards now. You don't have any energy to give off. So now you become cold. Only energy given off is heat. Do you understand? There's nothing to give off anymore. So it just drops right down to zero. One last thing before we get deep into this. I mean, it's not going to get deep. It's very, very simple. Like I said, it heats up until there's no more particles left. They're all gone. All you got is a black body. And that can't give anything off. And the only thing that heat is particles being given off. When you give particles off, that creates heat. You turn on your oven, your stove, and it runs the electricity through there. It's just shooting electrons off. That's all. Now, when you get this ultraviolet catastrophe, she drops like a rock. Everything here was done with that. Now, for some reason, and I have to believe it's a complete universe. It has the same frequency, which stabilizes, I believe it's approximately 1823 of these dipoles, which is a black and white particle, just like a bar magnet. At 1823, they lock in. And I'll show you this in some salt experiments, because salt is nothing more than a polar molecule, NaCl, one side and the other side of the periodic chart. And then they vibrate them. There's nothing more than pushing electrons in and off them. So they create a pattern based on a certain frequency. I'll show you. It's really very, very interesting. The key here is, once you get rid of all your particles, you can't emit. That means you don't have any heat. Heat is emission. That's all it is. Okay, just watch this. This is amazing. This is Latham's tractor beam magnets. Latham's crazy machines. Now, he's taken and he puts 6 magnets on the outside with one polarity, and he's putting the opposite polarity on the inside. So it's putting like the dark matter. Can you see that? Yes, you can. That is right here. He just made this. And these are the particles that surround the center core. Now, more particles want to get in. They come. But there's so many particles here, they push them away because they are only white particles. But they do precisely what he's showing here. And it will stay at that quantum distance. And watch what let me just show you something here. You see these two? It's right in between. It's always going to stay in that. It's going to be grabbed here and grabbed here. They will stay in, and another one will go in between 2 more. And then as they start to go out, one will come in between these 2. And then in the next row, one will come in between the next 2. And it'll keep getting bigger and bigger like this. But the very, very outside ones will be the red. They'll just fall off fairly easy. The ones that are right down here, they are tight. They are held very tightly. And they'll shake and shake and shake and shake and shake. All the other ones are gone by now. The red, the green, gone. The blue is still there. He says, oh, hell, I'm not leaving. I'm not leaving. Oh, yes, you are. Boom, gone. See you later. See it? Watch. It'll hold tight. Boom, 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 boom. See you later, buddy. All right, this is another fabulous one. This is Bruss Pup. Amazing resonance experiment. And what is resonance? It's shaking. Boom, 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 boom. And it appears that there must be a universal, throughout the entire universe, a same buzz, which makes electrons, these dipoles, congeal at 1823. They come together, they're sort of flopping all over, and they call it a particle zoo, and then all of a sudden at 1823, they lock in and they become a proton. 1824, which is not as neutral, because it has an even number of particles. So it doesn't want one more, and it doesn't want to give any away. It's comfortable and it's neutral. If a particle is charged, it means it either wants to take one on to become neutral, or it wants to give one up to become neutral. Therefore, a charged particle becomes part of a bigger mass of molecules called matter. Your neutral particles are a little bit different. They claim they're neutral, but I got to be honest with you. I don't really see anything being neutral. You know, at a certain point they're stable, but I don't see any neutral particles. That's my take on electron flood theory, and I'll show you why. Because every single dark core is coated with a pile of electrons. And then what happens? More want to get in, because that dark core is very attractive, as I will show you in a second. As you saw just a second ago, with that one wanted to get in, but it was stuck out here. And the bigger this internal core, the black, gets, the more it sucks. So you got one for hydrogen. All right? And hydrogen can have 2 or 3 electrons. Well, I'm going to show you right now the frequency that sets up hydrogen and helium. Those two are the same. Basically, only helium is a noble gas. See, it's down here. It has all of the electrons in its orbital, and it doesn't want to give any away, it won't take any in. All these are the same way. They say, I got exactly what I need to fulfill my stability. That's all it is. And the hydrogen says, I'm not stable at all. I am not stable whatsoever. Hydrogen is extremely explosive. Now, let me show you what hydrogen is in its nucleus. And its nucleus is going to have up to 4 electrons can surround it. And then up from there, both of these can have up to 4 electrons surrounding it. When you get up to here, you're into the rule of 8, this row and up, which means that 4 will turn into 8, and then the 8 will turn into more around it, and then it'll be bigger and bigger and bigger. That's the whole key. Now watch this. Tesla was exactly right. when you think in terms of energy, energy is caused by frequency and vibration. And what does frequency and vibration cause? There's got to be some hum in the universe. Now watch this. This is going to be salt particles on this table. And the table is just going, rah, 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 rah. That's what frequency is. Frequency is just a buzz of electricity causing this thing to vibrate. And when it vibrates, what does it do? It pushes electrons up and down, up and down, up and down, up and down. What does that do? It interacts with these polar molecules. A polar molecule, NaCl, you see it here? NaCl, that's salt. That has one electron, that has 7. They're just totally like a magnet, like a bar magnet. So these electrons shoving them at a certain frequency, they're going to make them stop. And it's stunning, the different frequencies. They start at a very low frequency. I think it's 345, something like that. I'll explain what's going on. They're putting salt. And this is that table, and when they put electricity in here, they can change the number of pulses that go to that plate per second. All right, they're called the hertz. Here it goes. So they start out vibrating the metal plate by using a tone generator. All right, now as the pitch of the tone increases, the geometric patterns, which you will see, form and become more complex. The first one is going to be this lowest ring row here. Now watch, they're going to be, what did they got? 345 hertz. Watch what happens. They're starting to vibrate, and now the salt is looking around for where it's going to become stable, and it's all congregating into this pattern. You see this? This right here, my friends, is hydrogen. And why do I say that? Because you can have a particle here, one here, and one here. These are the zones. These are the 4 different zones. Now you go up into the rule of 8. Here's the black particle. Whoops. There it goes again. I'll tell you, these black particles are hard to hold on to. So here's the black particle surrounded by the same number of white particles. All right, the black's in the center, which I just showed you, surrounded by the same number of particles. So if there's 1,823 in here, which for hydrogen there will be, there's going to be 1,823 particles out here. Now, what happens out here? One more particle, as I showed you with that attractive beam magnet, wants to get in. But these say, no, you can't. You have to stay in that little orbital out there. You have to stay here. You can stay there. You can go any one of those, but you can't get in here. We will not let you in here. And the white pushes the white away, and they stay out here in these orbits surrounding it. Want to get in, not allowed. That's what's called the orbitals. And this is the lowest orbital there is, which can have only a maximum of 4 electrons surrounding it, and that's what helium is. Helium is when you get to the 4 over here. And there, it's filled. It's not going to, nobody's going to add, nobody's going to take away. When you only have 1 or 2 here, it wants to fill these. It wants these filled. Helium says, no, I got all mine. I'm good to go. And the same thing happens when you get up here into neon and argon and krypton and xenon. All of those have 8, or well, after the 4, they go up into the rule of 8. At this row here, you go into the rule of 8. Well, they call them groups. I call them rows. These are periods. You know, they got all kinds of different little names. But anyway, this is the rule of the lowest particle, rule of 4. Now we go to the rule of 8. Watch what happens as they increase the frequency. And you can actually see the rule of 8 absolutely flawlessly. Here it comes. All right, so now let's look at what we got now. We got the same exact thing. We got the black ball in the center. We got all the white particles surrounding that single black center. And then we have 8 regions out here that surround this central core. Now we're into the rule of 8. And then it starts to get very exotic. All right, as we go up into the higher frequencies, it will get extremely exotic. All right, but you can always see they have the same push to shove. They're always, you stay away from me, I'll stay away from you. Same distance basically away because of this resonance frequency. You see it? There's the rule of 8 again. There's 8 of them surrounding, and then they cause all kinds of different patterns surrounding that. You see it? There's the rule of 8 again. There's the center core, the rule of 8, and then surrounding those patterns. And it just keeps going up until it gets so exotic that you can't hardly believe how exotic it gets. Okay, I've been doing this research for quite some time now in the subatomic realm, and electron flood theory, which is this dipole flood theory, is my theory. And this was a paper I wrote in 2019. Paul Amatucci is writing a new library of all my research. And there's another one, this is about ether particle theory, which is the universe is completely saturated with particles of light. These are particles, they're not particles, they are particles. All right, you see that? That's a particle. And that has mass. And I can prove to you that black part has mass and the white does not. The white is just a burner. And that's all it does is burn. It has no mass. The black one has all the mass. Now, I know you're going to say, Roger, how can you prove that to me? I will prove it to you right now, very simply. This is the light coming through here. The particles are starting to glow, and then the black part separates from the white. You can see that. You see them reattaching here. So this is completely white. All right? And the black comes after it, but we have it blocked so it can't get through. But if it could get through, it would follow it through, and I have a shot of that, where it's already come through with some black with it. So the next shot is going to be a wave like this, with the black pushing the white forward. Because some of the black was allowed through, and here's that shot right here. You see that? Some of the black got through. See the little bits of black got through here? And that is just what's pushing the white wave, particle wave duality. So the two of them together make the wave as they come forward. And normally it's a wave produced by a photon. This is a wave produced by literally sterile muons that are pushing electron showers in front of them. And that is exactly what they show somewhere, but I'll show you that later. That's exactly what they show at CERN and Fermilab, is that the muons and the electron neutrinos create sterile muons. The black ball goes all by itself, and the white turns into showers. Precisely what I'm showing you. There it is right here. That's just a pulsed laser coming through. There's the particle accelerating. There's the division. There's when it comes back together. I would call that fission and fusion. Fission means to come apart. It did. Fusion means to come back together. It did. Between here and here, that's raw, completely raw white energy. And that, to me, should be very, very powerful. And I've always had this idea right here of taking, because Rod Warren did this. Let me just show you what Rod did. And I've lost touch with him, so he's the guy that really knows how to make this work. And I've lost touch with him, so I don't know what to do now, to be honest with you. But here's what Rod did. He took just what you're seeing here. This is all he used, and he created a little tiny orifice which was rounded, so it created a venturi, which means a restriction. So all that stuff had to go through that restriction. These are big balls of magnetism. It's a little tiny particle, but it has a big field. And when they all had to go together, they said, ooh, and the white hates each other. They just stay away from me, and they just, and they glow like that. Now the black just couldn't make it through. The black was too big. But this was my hope we could do, is to take that beam just from a cheap laser, nothing special, and send it down. It comes with the black and the white here, as I showed you, no question about that. Here, no question that the black separates from the white. The white, if it hit a correct receiving metal plate, which would be transition metals now. They have all the different orbitals, and they can receive all these different energy frequency levels and send it down. They should become, and they've already been working with them. They call them perovskovites. And we should be able to send that down, because it's slapping it. It's like pulsing it. Boom, 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 boom. Every pulse of that pulsed red laser is nothing more than a construction laser. And it goes, and it picks up and tells you how far away things are. But in the meantime, it's pulsing and squirting this stuff right through, just like like a squirt gun. And when it comes out the other side, if we can harvest it right here, send that into our backup power supply, or run it right into whatever device, there should be a lot of energy there. If somebody knew what they were doing, and I really don't know what I'm doing, I got to be perfectly honest with you, but I see energy. And if we could put it in something like this, and they just did something with getting energy out of thin air. And they're doing basically what we're doing through nanotechnology devices. They're letting the white come through and absorbing it, but they're just absorbing light that's hitting it, very, very weak. We're absorbing really powerful. I think. I don't see any reason not to look into this, and it's been actually fought against by Fermilab for the last 6-7 years. And I understand, well, I don't understand necessarily why they're doing it, but it's not a good thing. Because I show exactly the identical particles that they're showing there. And this was the paper I finally wrote trying to get somebody to pay attention, and it certainly didn't happen. Anyway, I always end up with this sob story about, trying to show somebody and they just won't listen. Nobody listens to anything anymore, unless it fits exactly what they want to hear. Their ears are closed, their eyes are closed, their minds are closed, their doors are closed. They're in their own little world called peer review. If you don't say what all your buddies say, you ain't in there anymore. That's how it works. Okay, this is exactly what we show is an atomic bomb blast. It's identical. Okay, I'm going to tell you right now, it sounds crazy, but what I'm going to show you is a subatomic bomb blast right here. Through that venturi, we're sending out subatomic particles. They're smaller than atoms. The black is the pusher, this is the burner. I'm going to show you a house being burnt and then exploded. The burn comes here by these particles that have no mass. They just have energy. Then comes the ones that have the mass, and it knocks it down and blows the house right away. And here it comes. All right, check this out. This is a test house. They're exploding an atomic bomb. What happens in an atomic bomb is, as in all matter, the dark goes to the center. So what they do is they force this thing to compress, and then everything comes out. And the first stuff that comes out is the white. As I showed you right here, you're going to see that white come out first, and then followed by the black. So here comes the white. And all of the white particles are big, and then comes the black behind it. All right, the white has no mass. It burns. All it has is these electrical charges and no mass. And that is also confirmed by Fermilab. And I can show you the article that backs me up 100%. And this burns the house. This knocks the house down. And here it comes. All right, so here we are. Boom, the atomic bomb goes off. You ready? The atomic bomb goes off. You're going to see, whoops, let me turn this down so it goes a little slower. Let's go down to 25%, why not? All right, so now we're going to go forward here. You're going to see a brilliant white glow, which is all the atoms in the air are being excited. Boom! You see it? Every atom in the air. Now it's just burning up. It's just burning. Nothing's been moved. Not a single thing has moved. It's just everything combustible has combusted. Now watch what happens when the black particles come. There it goes. And now watch everything turn around and come back. Watch. See it? It's coming back because there's a void back here that has to be filled. All right, now watch it one more time. Here goes. Everything that is combustible will just vaporize. The wires, the poles, metal things obviously don't, because I'm sure they got heated up, but they didn't combust because they're not like combustible. All right, here goes. Just watch what happens. Just think about it. You can go back and play this and stop it here and there. But the first thing that happens, I will stop it. Boom. Everything's just white. 100% white. And you can see the wires and everything starting to glow. You see them? And burn. You see them up here? The poles, anything combustible, the roof, all the shingles, everything. And even the smoke doesn't hardly blow back. It's just sort of billowing up. There's no impact from the white. It has no mass to speak of. You can see the metal things don't do anything, but here all your wires are combusting. Anything that can combust, combusts. Anything that is able to absorb electrons. Now the dark is starting to come forward, but it's still, boom, there it goes. The black has hit. Now it's literally, I'll bet you, it's frozen cold. All right, this is our at the ultraviolet catastrophe. There's no more white particles, and we just saw them all leave. They're gone. Now comes the black ones, and they are cold as hell. I mean, cold as not hell. They're cold, cold. And we have the same thing in our outer atmosphere. We have a real hot zone, and then we have a real cold zone. And that's how everything works with this. Whenever you're pushing against it, you got a hot zone. Wherever it's not being pushed, you got a cold zone. All right, and then it turns around and all comes back. All right, so I hope that makes sense to you. That is nothing more than a subatomic nuclear bomb blast. The other one was an atomic bomb blast. Now, there's something else I want to show you, is this. You see these particles here? These are the same particles they found. Well, let me show you the Fermilab article. All right, it's the exact same particles we found. They call that the fixed, and this is the point particle. This one here gets bigger and smaller and fluffy, and that one just never changes. And that's exactly what it says down here at the bottom. In summary, the extended particles have a fixed size. That's the black one. They never change. They may have a fuzzy edge. That's the color. The point-like particles are mathematical extraction with zero size. I can't disagree with that. They don't seem to have any mass. But even zero-size particles have an extended effect, listen to this, due to the effect of the field surrounding them. That's exactly what happens. Those are the fields. And this is from the government, and this is from Fermilab. Don't forget, this is the same particle as that, only this one here, when you put it into its energy values, it shows these values. That's the one from behind it. Now, if that's correct, the colors that are being portrayed, and I believe they are, this is very interesting because they shouldn't fit that, they shouldn't go in that way. The blue should be on a very tight against the core, and then the green, and then the red. But the blue now is in between the two. That's, to me, very, very, very interesting. All right, this is the black body. And when the black body is the whole thing. And when that temperature gets up higher and higher, first of all, you give off the red frequencies, which are down here, which are way on the outside. So these ones here, they just go away. Those are the red. Then the green is left, a little lower. Then those go. Then the blue is left, a little lower. And then when those are gone, this is all you have left is the little black ones. They are so cold, they just drop. They're gamma rays at this point, and they're very, very, very destructive. Because they're the bombers. But the temperature just drops right off. There's nothing more to give off except these. And they hammer you, and that's why a gamma ray will kill you. All right, so that's the range. Now, how did the blue get in the center? That's what's got me confused. That's what's got me very confused. Now, as I showed you, the blue, I would expect the blue to be right in the center, and then the green, and then the red. But we're down into the tiniest bit of matter there is this, and it may not even be matter. It may just be a field. We saw it. It didn't move the house. And the reason I never thought you could separate the black from the white. Never ever in my wildest dreams did I think that was possible until I saw it. When I saw it, I said, how could this be possible? These are bar magnets. You can never make a bar magnet into half positive and half negative. Every time you cut it, you get a smaller bar magnet. Cut it 10 million times, you just get 10 million bar magnets. Well, guess what? When you get down to the range we're in, there's nowhere else to go. so when this one white leaves the black, it's gone, and the black goes on by itself. You see it? Watch. Right here. The white goes all by itself. There's not a single taste of black here. The black balls, they all stay exactly the same size, exactly the same, exactly identical. They never get big, they never get small. Those are the dark matter. And the only reason we can see them is because they're blocking out the white matter that's behind it. Normally you would never be able to see the dark matter. Nobody ever sees it because it's attached to the white matter, and the white matter bounces. Right here they're separated, we can tell. And there's no question it came apart here and they came back together here. Fission and fusion, that's all you can say. And this is subatomic, smaller than an atom. And again, this is basically the structure of atoms. This is what they didn't understand. This is the core. Now, depends how big this core is. This is still only the core. This is the black and this is the whites that would normally be one-on-one attached. You get to 1823, bam, it locks in. Then you get electrons way out here. They want to get into that black, but the black, the other white ones say no. They always push. You see, the white always pushes away. So if it has enough to fulfill its requirement, nobody's going to be allowed in. That's what the valence electrons are. They surround, and then more and more and more come in as that gets bigger and bigger and bigger. So atoms that have more and more mass in the cores will have more and more electrons clouding around the outside. It's not hard to understand, but the black and white particles in the center are dipole particles. This was my Rogers atomic dipole theory, a dipole flood theory. And it is. That's what makes up everything, is these two little particles, the black one and the white one. 100%, as far as I can figure, 100% of the universe has got to be made of these two particles. These two particles right here. And that's what they see at the atom crasher when they smash into bits. They can see it, but it's only like in trash. They see it and they say, ooh, these got to be the smallest particles there ever were. And they're right. But then they see a zoo of other particles, and they think they are elementary particles as well. They're not. They're constructed of these two particles. That's the only two particles that exist, and they make everything else. Okay, this is as simple as this. CERN and Fermilab and all the colliders are using gigantic particles, protons and neutrons, smashing them together and getting debris like this. So here's what they do. They take huge, huge particles, smash them together, and they get what they call a particle zoo. And you're going to see all these are very, very familiar particles because we get them too, only we're only using light. Here's what they get. This is the debris. It's just trash. So they take them, smash, and then they dig through, and they say, ooh, the smallest particles that we can find are these little bitty ones, and that's the red and the black one. And why do they see so much of this red? Because the red is just weak. It's sort of floppy. It sort of bangs around. It doesn't go anywhere. To get the blue to move, it's going to take off and never come back. Same thing with the green, same thing with the yellow, same thing with the white. They take off and never come back. The red sort of just bounces around out there. It doesn't have any real energy to speak of. Now, the other ones are attached tightly. That's the key, to get them to go. And that's why you have this here. You have to get it hotter and hotter and hotter, which means you have to force more and more electrons to force them in, and then when they're finally all gone, you reach that catastrophe. Where was I going with this? We got this. Now I've shown all these particles. This particle right here is the photon. When that deconstructs, which they've done it, they do it too, they end up with this, the red and the blue, same thing. They find those laying around here and there. They see more different energetic levels of the photon, which we do too. This is just a chunk of whatever. It's X size, they don't know what size it's going to be, but because it's just part of an atom. These are starting with huge, huge, huge particles compared to ours. Gigantic. But they see all the same stuff. They just think they're all elementary particles, which they are not, and that's because they're working with this a mess of particles. We do this. We come through the Venturi here. Now looking into that Venturi, what would you see? What would you see? This is white light. Let's see what we see. This is looking, well, it's not really looking into the Venturi, but I do have something to. This is looking down at where the light is splashing into just the air. This is just the air. This is what they're talking about, getting electricity out of thin air. Because I'm going to tell you right now, that, my friends, is a ton of energy. Whether or not we can use it, whether or not it really is, I'm not certain. It sure looks like it to me. Okay, this was what I was talking about. They are basically doing something similar to what we are. They use a new invention, generates electricity out of thin air, offers clean energy 24/7. But they're only harvesting ambient light, basically. So we're putting ambient light through Venturis to split the particles so that we can harvest strictly the white part. That's the part that does the work. So this was my vision for the future here, would be to send lasers through these little Venturis, like the laser goes through a Venturi, and we harvest just the white down into, and it slams it. You can pulse it. All right, the pulse is how hard you're going to slap that through the white, through this Venturi. If the Venturi is tuned correctly, the black will not come through, but it will force the white, because it pushes the white. I've shown this very, very, very clearly. That black will force that white. Bam, 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 bam. So now you make a Venturi here, which would be like here and here. All that stuff coming down can't just go the way it wants to go. It has to come down into the Venturi. When it does, the blacks will pile up back here, and they'll just be bam, 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 and they squirt through the Venturi, as we see down below. We've done it already. Here it is right here. They're piling up back here, bam, 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 bam. And every time it does it, it squirts one through here. Well, it squirts a whole batch of them. And that's the white showers. And that's something I'm not making up. That's from CERN. All right, I'm just going to run through these real quick. I might have shown you 10 times already, but this would be a number 11. That's a spinning particle. And you can see how it glows in the center because there's so many of them packed there. And then it creates these little globs on the outside. That was what really interested me. My work, I played around to try to figure out why these globs are interspaced the way they are. And I used a double axis thing. Rod used a single on like this here. Now you can see his particles spinning there. And that's only this. This is exactly what he used. That's exactly it. And it's coming through here like a drill bit. So it's spinning, I believe it's spinning to the right. That's the right-hand rule. And it's making these little bumps. Those bumps were really what intrigued the heck out of me. And the blue is a lot more intense than the green or the red. But it seems to have this same patterning. And I do understand it now, I believe. The green, same thing, same patterning. You say, well, Roger, why? Well, maybe I'll tell you, but I'm not going to tell you today. Same thing, the red. Roger, why? Tell us, please. Nope, not today. Anyway, here we go. There's a lot to this, and you can't tell it in 10 minutes. And I know I've gone too long for most people's attention already. Here's a particle spinning. You see whenever they come close to each other, they bang into each other and they glow. And all it is the particles spin like this. They're coming through here spinning. And the red ones are like this, real slow. And the blue ones are like this. And I show that too. Somewhere. Here's the blue ones. You see the blue ones coming in like rocket ship. And that's right after the Venturi is spinning faster than hell. And then they slow down, slow down, slow down, slow down. But they're still very, 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 very fast and energetic compared to the green and the red. The green and the red is just not powerful at all. The green is very concussive. I think I've made my case. And the reason that we have the ultraviolet catastrophe is when you hit this temperature, all the electrons are gone. They're out of there. So it just zip, drops like a rock. I showed you in the atomic bomb, they can separate very easily. Just the way it is. We need a new atomic model, which I have. It's called the Rogers Atomic Dipole Flood Theory, because everything is flooded with these dipoles. There's nothing but those dipoles. And as they add together, they create matter.